Hi, everybody. This is Monica Paolini from Senza Fili, and today I'm talking to Lorcan Burke. He's the Director of Global Service Providers at VMware. The topic of the conversation today is power efficiency, and this is a topic that is attracting a lot of attention because of the needs that service providers have to increase the energy efficiency. And VMware is doing a lot of work on different fronts. And so it's great to talk to Lorcan about it because he's doing a lot of work on it. So Lorcan, can you tell us a little bit about yourself, your role at VMware, and what VMware is about?
Thanks, Monica. My name is Lorcan Burke. Look after our strategy and architecture and innovation tracks in VMware for our global service provider customers. A lot of that involves taking our long history of compressing or managing workload onto a smaller set of compute infrastructure for the last 25 years, making that work across multiple cloud environments, whether it's public cloud, private cloud, and then extending out our workload management capability from IT to core to the RAN in telco environments.
This is very exciting, and I guess that for you, the power efficiency has been, essential component from day one. Because clearly, you want to improve performance, and but energy efficiency is not the latest topic or the latest focus of work.
No, I mean, exactly. So if you look at the history of VMware, when the business started 25 years ago, compute was relatively scarce resource, very expensive to buy disk drives. A lot of what was being done was running virtual machines inside single physical machines. And as that extended over time, you allow workload or IT workload to be moved around to most appropriate resource. You extend the life cycle of older compute as long as you can, introduce new compute architectures, and hide that away from the application, so it makes it easier to innovate quicker. And then at the core of everything we've done has really been energy efficiency or carbon avoidance. And it's the name of how it's been measured has changed a few times, but for the most part, it's just being about more efficient with your compute architecture.
Absolutely, and yeah, so you want to increase performance and reduce consumption at the same time, so you don't need to have a trade-off. You just a net positive. How do you think that energy efficiency matters to your customers? Clearly, it's a top of mind issue, but at the same time, it seems like not all the operators and other service providers are considering just as important as others. There's quite some variability out there.
There is. If you look at national energy consumption in a couple of countries, you'll often find that the train infrastructure, train and public transport infrastructure might be 4 or 5% of the grid. The telecoms infrastructure, including the fixed line part, is often 3 or 4%, so similar size to the national transport infrastructure. And then in some countries, you'll find the data center infrastructure consuming significant amounts of energy, 15, 20% of the grid can be used with data centers. And that tends to be quite concentrated, the data center part, but the telcos are consistent, fairly high energy users, particularly with fixed line infrastructure. On mobile infrastructure, they have a lot of distributed power requirements as well to base stations, as well as some data center data requirements and energy requirements. So there's a real need to optimize use of that energy, make sure it's being used fairly. There's other requirements in grids like powering hospitals, powering other infrastructure, emergency services requirements. So you have to be conscious of what you're doing. And I see in the last year maybe a return to real demand for efficiency in use in that energy, not just carbon footprint, but which is a big part of it, but also just reduction in that energy usage.
Absolutely, yeah, and there are different ways to go about it. Can you tell us a little bit more about how do you help your customers in terms of the high level, and then we can go and deep down and talk about specific solutions, because you are working on very different fronts. But what is your general proposition, first of all, to your customers?
Yeah, so generally we found some interesting things have happened maybe over the last 10 years. People have assumed compute is a very abundant resource. So, and it is, relatively speaking, very cheap to to get access to the right sort of compute. You can buy it on a capital basis. You can buy it on a as a service basis. You can spin up things very fast. And then as software languages have become higher and higher level, the need for optimization has maybe drifted away a little bit. So we're finding a lot of customers looking at, first off, just are there basic things I can do with my compute infrastructure to make it work better? So we've been working with Intel on some of their energy management states, P states, C states, they're called, right? So how do you condense the workload on a compute platform when it's not being used? How do you make applications aware of that? So how do we expose some of that? So we're seeing some significant energy savings potentials there. Then there's basic hardware and software settings, BIOS. People haven't looked at some of these settings for a long time. There's extreme energy saving modes that we've had around for a long time, 10 plus years. People have forgotten about, so we're redoing some of that work again. Then you think about, how do I use my storage better? Often you find people are duplicating data over and over again. Storage, particularly real-time storage, is still quite expensive to run. So if I can condense or reduce the number of copies, reduce the times I back up that data, I can significantly change energy use. And then I can reduce overall workload. And as I reduce overall workload, or remove redundant applications or modernize those applications, I can save a significant amount of energy. So it tends to be a process of looking at what you've got. How do I tidy it up? How do I then make it think about more modern application infrastructure? And then how do I leverage the multiple cloud environment around me, around which of those data centers might help me reduce my energy cost, and which practices might help me just write better software and use those assets more efficiently.
I guess that what you said sort of made me think that, maybe we, as the price of service, the price of compute went down, we kind of, like, as an industry, become a little bit lazy, like,
yes,
don't care so much. And now the tide is turning, because that laziness turns out to be very expensive. So
yes,
we need to do something. But sort of before you go to a solution, you need to understand how big the problem is, or what is it you're trying to do. So you need to measure not just power consumption, but also power efficiency.
yeah.
So how do we go about that first step?
So in the data centers have some standard ways of representing their power efficiency. So effectively the amount of energy used per unit compute, in effect, right? So there's a lot of very simple steps you can take around auditing the position you're in now, and how far away you are from an ideal PUE, or a power usage efficiency. So those are things where we often find people with large data centers just saying, where am I? How do I audit what I'm doing? And then how do I start fixing it? So we've good tools in ARIA, which allow us to help expose some of that information, and then help also add either a green score or a carbon score to help people measure their carbon impact with that infrastructure. So there's very simple things that are widely available associated with the platforms we provide, which people can start with. And then once they've measured that, then they can start looking at how they optimize.
So what is the green scores? Is that?
Yeah, so green scores, part of what we've been doing from a multi-cloud perspective is we take available carbon information from all the data centers we work with. We've also got a significant number of data center partners who are zero carbon committed. So they have a commitment to drive out carbon use in their infrastructure. And we help take that information and report on that company-wide for people, so that they can say, whichever cloud I'm in, how much carbon am I using? What's the effective carbon footprint of some of those locations maybe I'm using? So you have some countries that are running almost exclusively the electricity grid on gas, so they tend to be quite carbon heavy. Ireland, Netherlands, significant amount of wind. How do we help represent that? And then people like Germany, who would have a mix of wind and coal, how do we help people understand the amount of carbon being used, time of day, day of week, and how to help them optimize their IT usage to match that green carbon?
So basically, they have a way to look at their consumption, which is independent of the source of energy, and also to match it with the energy sources. So you help them with their renewable strategy, effectively.
Yeah. So within the green scores we have within ARIA, we're taking knowledge from multiple data center partners. So whether that's the hyperscalers or other local data center providers, or global data center providers, knowing the mix of energy on their grids. So whether it's likes of Central European, where it might be more coal with a blended wind, Ireland or Netherlands, where you might have more wind and less coal, or different energy sources, which would give a different carbon score. How do we represent that in a way where people can look at their global data center footprint on multiple clouds and help decide where their workload should run, and can they maximize that workload placement to minimize the amount of carbon they use? So global initiative, we've got some national scale activities looking at connecting wind farms, measuring directly off renewables on grid, how those are getting matched up with workload inside data centers, and doing simple things like, if you're moving data around for backups, do you need to do it in the middle of the day? Can you wait to when there's available renewables on the grid? And if you can share that information between the grid and the generation side and the IT side, maybe people will start making some slightly different decisions about when they do things, and significantly impact both their carbon footprint. And highly correlated with low carbon energy sources like wind is it's cheaper energy anyway. So you have a double benefit of reduced carbon and reduced energy bills.
Absolutely, yeah, and I guess the the cost savings are also quite substantial. So it's not just good for the environment; it's also good for the bottom line.
Exactly.
And now you mentioned that you might learn, by looking at your consumption, and power availability in this case, you're going to do things differently. So it's sort of an ongoing process of learning, and I guess it's not only in the way you operate the network, but also how you plan it. So as you get into a more virtualized networks, you have more flexibility, and you can decide to deploy your network in a more centralized or distributed way. How do you see that working out in terms of power efficiency?
Yeah, it's an interesting one, right? So one of the things that's tricky with telecoms networks is maybe people haven't been measuring their energy usage end to end quite so much for a long time. So we've kicked off a number of research projects, collaborative research projects, multiple parties involved, looking at everything from how do I think about my transport network architecture, whether I'm using passive optical networks or active optical, looking at base stations, when we're doing an open RAN or we're taking apart radio and reassembling, how much is in massive MIMO using extra energy versus might be in lower order MIMO. How do I steer traffic across those using open APIs in the network, using things like the RAN intelligent controllers, to be able to think about exposing information to allow me to measure. And if I'm measuring, then how do I control? And then all the way back into the core, right? How much of the core network stays in, it gets consolidated into maybe lower number of data centers, which can be built more efficiently, or how much of those functions need to be pushed right out towards the edge. Now, at least if you've got some thinking about common cloud platforms, you can start thinking about more dynamically moving that. You've got some common APIs or control plane, so you can start running that operationally more efficiently. And all these networks have traffic patterns, right? So time of day, day of week, holidays, even in some networks which might have fixed wireless access running on the mobile network, they have extended busy hours, but they still have quiet times in the day. So when we look at the quiet times, can we consolidate workload to a smaller number of physical compute environments? Well, the answer is almost always yes. What's the risk associated with that? How quickly can you spin back the resource in case of emergency or things going that need the assets quickly? They're things we're working on to try and balance off the change in overall network KPI in availability, in effect, and the overall energy score or carbon impact of those networks. So yeah.
Yeah, and this is quite important because if you deploy a network, you deploy a network based, you dimension it on peak.
Yeah.
But peak, as you say, is not there all the time, so by definition. And so how is that changed? Because clearly there's always been a way to kind of do a little bit of sleep, but how is that changing? Are we getting more sophisticated, and especially with like AI automation, are they changing the way this is being done?
So yeah, I mean, the answer is yes. How mature, using machine learning or knowledge-based systems or early neural networks in telecoms has been going on for quite a while. Some of the things we've worked with in plugfests, for instance, have been looking at use of machine learning to start looking at different traffic patterns in the network. You may then have multiple applications running to try and optimize the network. they'll often have conflicting requirements. Somebody wants max performance, somebody wants max energy efficiency. You have to have some effective adult in the room that's allowed to make decisions as to, are you still achieving the right objective? So we've been doing a bunch of work on that with multiple operators around the world. So that's getting quite a lot of thinking at the moment, and it's also one of the first times we've had, maybe in the last 10 or 15 years, where you have a more truly open environment to expose that information for performance, and you can start making some real decisions about that.
No, absolutely. So, so there's a lot of work that can be done, but also with the introduction of Open RAN, and you've been very active on that front, how is that changing the way we think and manage power energy efficiency?
So yeah, there's a few things that it enables, right? And it's not just for the Open RAN side. It turns out a lot of the techniques enabled by Open RAN will work on existing radio infrastructures from major existing equipment vendors, right? So we've been taking classic performance information, which might have been available on a 15-minute interval, and there's also performance information available maybe in a slightly more closed manner on a 5-minute interval basis. We take that information, look at it on a per user basis, help decide where workload might be placed. So you may have some partners to these mobile operators that will have significant amount of short form video, as an example, right? So when you have short form video, it tends to have a very non-optimal performance from the mobile network. The mobile network tends to like slightly longer form videos, settle down the traffic path to an end user. If you've got lots of short form stuff and people chopping a lot, the network isn't quite so good at responding to that. And overall, we tend to throttle network traffic when we think we're in congestion, but maybe we could do some more fine-grained control. So some of the things we've been exploring is, how do you really let the control in the network understand what's going on inside it? And then how do you make more active decisions as to which traffic you allow through, which traffic you might throttle or scale back? And then how do you manage that more effectively overall? And I sense a real change in behavior between different stakeholders and these operators, where they would have historically said, no, it's my network, I'm going to decide what I control. And you can only play when I say you can play. And all of a sudden, you've got these big traffic sources, and it still gets into the fair use debate in the EU, right? How do you decide fair use? Well, fair use, the other side of fair use is fair quality, right? So if you give me fair quality, I can then decide what fair use is. And then maybe we can figure out a good settlement arrangement around that, which is how GSM really started, right? I mean, Global System for Mobile, Group Spécial Mobile, we sat down in rooms and we figured out how roaming worked with competitive partners. It's the same thing, right? So if we can figure out how we bring these communities together, we can then maybe run these networks more effectively and give overall better end user performance.
Yeah, and I guess that the question of being fair from the user point of view in terms of what you allow is also going to be related to power efficiency, because if it's something very inefficient, is it fair?
Yep.
So it is at some point a trade-off, but it goes to the trade-off of fairness. It's not just a question of being, trying to limit the user experience. Now, what about the RIC? Because that's where I say you mentioned how you manage basically traffic. So is the RIC going to have to play a role in increasing power efficiency?
So there's a number of communities working on requirements in the areas of near real time and non-real time control in networks. So the Open RAN Alliance community have been doing quite a bit of work on gathering requirements, putting together plugfests, really working to figure out where the RIC can play a role. And the telecom infrastructure project team, the TIP guys in the RAN intelligence and automation community, have significant requirements in terms of spectrum efficiency, energy efficiency, and all of these tend to come together. Either I'm trying to make the end user experience very fast or very efficient, and the other side of it about making it very energy efficient. They tend to converge over time, but at the moment we're seeing people quite concerned with newer technologies going in the network which might use more power. How do I then use the controller that allows me to reduce the power and then reintegrate a system to make it more energy efficient? So the RIC or RICs play quite a significant role in that. And it's also one of the first times that the operator community have had the ability to start playing with technology to enable different services in their networks. And then as they look at these services, they can make an assessment on the energy impact in those networks, because they can measure and expose that information externally to the current system.
Yeah. Do you have any direct involvement in how you're driving this, the RIC, I would say the RIC system?
Yeah, I mean, we VMware does. We've been running intelligence and automation in radio networks for a number of years. So we've been optimizing not just Open RAN, but existing radio networks for quite a long time, using real-time and non-real-time information. We've got some very innovative things we've done with collaboratively with Intel and Vodafone publicly, which around, and Cohere, around spectrum efficiency. So really pushing the envelope on how do you deliver more bits per hertz per cubic meter per watt, if you like. So how do I really think about placing capacity for multiple users in real time the right way, in the most energy efficient way? So those are things that we've innovated on and are now working together to see how we accelerate those into the market. So yeah, a lot's being done on how do you more efficiently use spectrum in the radio network.
And this is specific to wireless networks, but then there's also sort of a wider increase in efficiency in data centers, which are not necessarily telco ones. And that's might be, are you doing also work on the hardware side of things, so to optimize power consumption there?
Yeah, very much. I mean, we mentioned earlier the joint work we have in data center with Intel on P states and C states. So some of those states are very applicable to some of the real-time network components we use, but equally applicable in classic IT or other data centers. So a lot of work looking at how do you do performance characterization of some of these real-time network components, take advantage of sleep states, P states, C states, just how do you condense workload down, and how do you effectively power off and recover servers as quickly as you can. So a lot of work at that level. Disk drive optimization, virtual storage area networking, so the whole area of storage. Again, big requirement in all data centers. How do I manage storage? A lot of work on how do we reduce the impact of storage and help people deduplicate data. Every duplicate copy that's available real time takes energy, right? So if we can help people deduplicate data, that's a significant energy saving.
Another source of energy consumption is cooling. Is that getting any more efficient?
Yeah, so cooling is another one. So typically, we see a lot of people looking at heat exchange programs around data centers, right? So it may be powering community heating systems, swimming pools, all of that. But fundamentally, it's still better if you reduce the amount of energy you're using, or reduce the amount of cooling required in the data center. So we've been doing work on extreme deep cooling in multiple markets. How do we look at data center design around doing that, and then how do we really leverage the that heat exchange capability to reduce the overall air conditioning requirements in these data centers, because it's a big energy user.
Absolutely. Now, you're working in many directions, but if we were to sort of look forward, where do you see the biggest opportunity to increase energy efficiency?
Oh, good question, Monica. Where do we see the biggest opportunity to increase energy efficiency? I think there's a few answers to that. There's quick things we can do, right? Just get back to auditing extreme energy saving settings in the data center. Right? That can be done immediately. We can audit that. We can just implement different settings and assess the risk of that straight away, right? So there, I do think there's things we can do immediately, short term, to help people's energy bills. On the medium term, if I look at 6, 9, 12 months, I think helping particularly the telcos look at their traffic patterns in the network, and then look at condensing workload when it's not needed, right? So we, as we said earlier, when I do traffic planning, I tend to get a number, I forecast it, and maybe in the IP network, I might double it again, right, just in case. For some of my compute infrastructure, we haven't really got the equivalent of what we had in the voice network for Erlang. So how do we create something that does that? So I think there's some research topics on that, which are kind of medium term. And then I think there's some midterm things we can do, which will significantly save energy in the quiet times in these networks, but still allow a good quality accessibility KPI to be met. And then long term, I think we need to do real research around how we think about building these networks. and include the energy efficiency in that. So I think as an industry, we've become slightly guilty of the excess of cheap compute over the last couple of years. It is cheap, it's good quality, but we need to think a little bit more about how we use it. And then I think we need to get discipline back in our software development processes that puts that control back in the hand of the developer. So I think as the next wave of development community comes onto the telecoms environment and IT environment, I think they will want to see that they can control the energy that they're using directly. So how do we expose that over the next couple of years so developers can put those decisions back in their own hands?
Absolutely, and that's going to be a lot of work and a lot of learning, and it's actually fascinating because there's a lot of opportunities that we have. We just need to understand exactly what we need and how to get there. So, Lorcan, thank you so much for sharing your thoughts with us today.
Oh, thank you very much for spending the time, Monica. Really appreciate it.
And thank you all for watching. And you can also read a transcript of this interview. And this interview is part of a report on energy efficiency in wireless in the RAN and beyond. And you can get the full report in the Senza Fili website. Thank you all.